Today we're going to work on the Chapter 2 study guide for our test tomorrow. Remote learners, please remember that you are expected to take your geometry test during your scheduled geometry period. Please look at your email. I'll send you a few reminders on exactly what time that is. So the hexagon below is surrounded by 12 dots. How many hexagons will be in the fifth figure of this pattern? As you can see, I already started drawing a little bit here. So this first hexagon, we only have one. In my second figure, I have three. 1, 2, 3. In my third figure, I have 1, 2, 3, 4, 5, 6. And in the fourth figure, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so I'm going from 1 to 3 hexagons. I added 2 hexagons. From going from 3 to 6, I added 3 hexagons. From 6 to 10, I added 4 hexagons. So how many hexagons am I going to add for the fifth figure? Well, that's going to be 5. So 10 plus 5 is going to equal 15. Now B is our challenge problem. Which figure of the pattern will have 28 hexagons? So if our figure here would have had 15, if I add 6 here, our sixth figure would have had 21. And then if I added 7, the seventh figure here would have had 28. Getting close to the edge here. Oops. So our answer here is the 7th figure. All right, number 2, write the next 3 numbers in the pattern. So I have 10, 15, 21, 28. I am adding here. So if I look from 10 to 15, that was plus 5. 15 to 21, that was plus 6. 21 to 28, that was plus 7, which means the next one is going to be plus 8. All right, and if I add 8, that gives me 36. So here I'm going to add 9. That would be 45. And then I'm going to add 10, and that would be 55. And number 3, fill in the missing numbers in the pattern. So I have 2, 4, blank, 16, 32. I'm not adding here. It's pretty obvious to see because 2 to 4 would be adding of 2, but 16 to 32 is not adding 2. Instead, I'm multiplying, which means I'm multiplying by 2 on each side or each time. So 2 times 4 would give me 8. 8 times 2 is 16. 16 times 2 is 32. And then 32, I got to multiply that by 2, and you end up getting 64. All right, next we're going to start finding some counterexamples. So find a counterexample to disprove the conjecture. The value of x raised to the third power is always greater than the value of x. So, something that they could have said was, well, 2 to the third is equal to 8. So 8 is greater than 2, so that would work. So we need to find an example where this would not work. And an example here would be any x value that is negative. So if I did negative 2 raised to the third power, that would equal negative 8. Negative 8 is not greater than negative 2, so any negative numbers would work to disprove this conjecture. Number 5, find a counterexample to disprove this conjecture. Irregular polygons always have an even number of sides. We know this is not true because there are some regular polygons that have odd sides, such as a pentagon. All right, a pentagon has 5 sides. So there are many other ones that you could have used, but I'll use pentagon in this case. Number 6, find a counterexample to disprove this conjecture. If x is If x is greater than 5, then x is also greater than 10. There's a lot that you could choose. Any number between 6 and 9 would work here because, and I'll say 6. 6 is greater than 5, but 6 is not greater than 10. So you could use 6, 7, 8, or 9 to disprove this conjecture. Number 7, rewrite the statement as a biconditional statement. Remember, a biconditional is if and only if statement. So I'll write if with 2 F's. So if Chris is elected class president, then he has the most votes. If Chris has the most votes, then he will be elected class president. So the biconditional statement then would be Chris is elected class president if and only if he has the most votes. And we're done. All right, number 8, which statement is the reflexive property, which is the symmetric property, and which is the transitive property? So the first one here would be the symmetric, and it's just a mirror image of each other. If AB is congruent to CD, then CD is congruent to AB. The next one, angle P is congruent to angle P. That's the silly one. That's reflexive, just saying something is equal to itself or congruent to itself. And then from process of elimination, this last one is an example of the transitive property. If 6 is congruent to 7 and 7 is congruent to 8, therefore 6 is congruent to 8. So we can kind of just see that those are congruent then. It's very similar to the law of Sill from from the beginning of this section. All right, number 9, solve the equation and write a reason for each step. So this was first given to us, 6 times the quantity x plus 4 is equal to 60. Given I don't need to rewrite that since it's already in my proof. So the next thing I'm going to do is I can distribute this inside the parenthesis. So I end up getting 6x plus 24 is equal to 60. What property was that? The distributive. All right, next I'm going to subtract 24 from each side. So 6x is equal to 36, and that was a subtraction property. And then finally, divide by 6, divide by 6. So x is equal to 6. That would be the division property. Moving on to number 10. Number 10 is a proof for us. Yay, our favorite. Okay. What's nice about your test tomorrow, it is on Polaris, which means you won't have to fill in a blank proof like this. You will have some hints and some drop-down menus so that you can see what you should be using. So first, what's the first thing I need to write for my proofs? It's always the given. So I'm given that angle 1 is congruent to angle 3, and our reason, they gave that to us, so given. I'm actually going to mark this in my diagram so I see that angle 1 and angle 3 are congruent. Those are what those marks mean. I want to prove that angle 1 is congruent to angle 4. So before I can do that, I need to prove that angle 3 is congruent to angle 4. And they are congruent because they are vertical angles. So they're vertical angles. So now that I know that angle 1 is congruent to angle 3 is congruent to angle 4, therefore Angle 1 is congruent to angle 4 because of the transitive property. And I'm done with my proof. Number 11, if x is equal to 3, then 2x plus 4 is equal to 10. I want to find the converse, inverse, and contrapositive. Remember, the converse is just taking your sentence, your P and Q, and just flipping it around. So this would be if 2x plus 4 is equal to 10, then x is equal to 3. The inverse is taking your conditional statement, your P and Q, and negating it. So it would be if x is not equal to 3, then 2x plus 4 is not equal to 10. And the contrapositive is actually going to take the inverse and flip those two sentences around. So if 2x plus 4 is not equal to 10, then x is not equal to 3. Number 12, we want to solve the equation for y. So I want to get y by itself. The first thing I'm going to do is add 4x to each side. So this then cancels, and I'm left with 2y is equal to, remember, I cannot add 16 and 4x together. They're not the same term. So this is just going to be 4x plus 16. I can't combine them together. And then finally, to get y by itself, I need to get rid of that 2. So I'm going to divide by 2, divide by 2, divide by 2. And so y is equal to 2x plus 8. I want to do the same thing for part B. So the first thing I'm going to do is subtract 12x, subtract 12x. So I'm left with 4y is equal to negative 12x plus 40. Then I'm going to divide by 4, divide by 4, divide by 4. So y is equal to negative 3x plus 10. And this is important in case we need to graph one of these or find the graph of these equations. We needed to put these forms into slope-intercept form. And we'll learn more about this in Chapter 3, but this is kind of just getting us prepared. You won't actually have to do this on the test. I figured this would be a good spot to just kind of refresh our memory on this. So don't worry about number 12 for the test tomorrow, but you might have to solve an equation, but mostly it's going to be exactly how number 9 was rather than number 12 here. All right, number 13. Find the values of x and y. So let's start with x. If I look at my angles here, I see that I have a linear pair, which means they add up to 180 degrees. So 3x plus 10 plus 5x minus 14 is equal to 180. Combine like terms. So 8x plus, I have a positive 10 minus 14. So I can actually, I should have made this in a subtraction rather than having that addition there, but that's okay, is equal to 180. So I'm going to add 4 to each side. So 8x is equal to 184. So therefore, x is equal to 23. All right. So if I plug 23 in for x in both these equations, I end up getting that this is 79 degrees, and I get that this is 101 degrees. Now, this angle here is going to help us to find y, because we'll also notice that these two angles here are supplementary angles. Or you could use this angle here because these two angles are vertical angles. So there's two ways that you can do this. I'll use the vertical angles. So 79 degrees is equal to 2y plus 19. I'm going to subtract 19 from each side, which gives me 60 is equal to 2y. Therefore, 30 is equal to y. So I solve for x and y there. Number 14, if angle A and angle B are vertical angles, and angle A is equal to 7x plus 3, and angle B is equal to 80, find x. So vertical angles means that their measures are the same, so I'm just going to set these two equations equal to each other. So 7x plus 3 is equal to 80. Subtract 3 from each side, 7x is equal to 77. Therefore, x is equal to 11. I only needed to find x, so I'm done. We're going to use our sentences again for number 15. So if a polygon is equilateral, that is P, and then it has all congruent sides, that is Q. So the converse is taking those P and Q sentences and flipping them. So if it has all congruent, I'm going to use that symbol, sides. Then the polygon, I'm just going to put poly, is equilateral. And I'm just going to put equal. All right, inverse is taking our P and Q and negating it. So if the polygon is not equilateral, then I'll just say it. Then all sides are not congruent. And then the contrapositive is taking your inverse and then just flipping those sentences around. So if all sides are not congruent, then the polygon is not equilateral. All right, number 16, we have another proof here. So once again, you would not have to fill out a blank proof like this. You would be given some things. So this is actually harder than what you'll have on the test tomorrow. So we're given that segment PQ is congruent to segment RS. We want to prove that R is the midpoint of segment SQ. So remember, the first thing we always write down or put down is that the given. So segment PQ is congruent to segment RS, and that was given. So next, I'm actually going to mark that in my diagram. So PQ is congruent to RS, and I'm sorry, I said we had to prove this. That was also a given, is that I marked the wrong thing in the diagram. I'm sorry. So let me slow down. Okay, so PQ is congruent to RS. So PQ is right here, RS is right here. R is the midpoint of SQ. That was a given. So I'm going to write that down for number 2. So R is midpoint of SQ. That was also a given. All right, so here is point R. It's in the middle of SQ, which means those are congruent. So since I know that those are congruent because R is the midpoint, I need to now write that down. So QR is congruent to RS, which I'll highlight again. QR is congruent to RS because R is the midpoint. That was our given. And the reason, that's the definition of a midpoint. Okay, so now we wanted to prove that PQ, which is right here, is the same length as QR, And if you look at your diagram, I have one tick mark on each of those, which means that they are congruent, so I proved it. So PR is congruent to QR, and the reason was substitution. All right, so looking at our diagram, we prove that. Next, write the following statement as a conditional. Every rectangle has 4 right angles. Remember, a conditional is an if and only if statement. So to write this as an if and only if, I would say if it is a rectangle, then it has 4 right angles. And I'm done. Next, we're going to make a valid conclusion from the 2 statements. So this we're either using law of Sill or law of detachment. So if you order an apple pie, then you will be served ice cream. You ordered an Joe ordered an apple pie. Therefore, Joe was served ice cream. Next, B, if you eat too much turkey, you will get sick. We are told that Abby got sick. What can we conclude? This is actually invalid. We cannot conclude anything. The last part, if angle 2 is acute, then angle 3 is obtuse. If angle 3 is obtuse, then angle 4 is acute. Therefore, if angle 2 is acute, then angle 4 is also acute. And this is the law of Sill. So this was detachment, and this was the law of Sill. Our last question, true or false? Through any 3 points, there is exactly 1 line. That is false. You only need 2 points to have a line. The intersection of 2 planes is a line. That is true. And finally, 2 lines can intersect in more than 1 point. That is false. If you have 2 lines, they can only intersect at 1 point.